Okay, so in this video I'm going to take a look at practical task 1 and how we can essentially carry it out using a circuit simulator. So the first thing we're going to do is we're going to build this circuit here. So we're going to build, we've got a 6-volt power source, we've got 3 ammeters, and we've got 2 different size resistors. So let's see what that actually looks like. So let's give us a power source, and you can click on it and change its value. So we want 6 volts, so let's do that. And then what we want is I'm going to try and make the diagram look as close to this one as we can. So we want an ammeter, which is, we can get this one. And we'll have that going down the side. Then we want a resistor. Now you want it to be 5 ohms. There we go. Then it needs to go through another ammeter. So let's stick another one of those in there. Then we want another resistor, which is 10 ohms, which I think they are by default. Then we need another ammeter. This is where it starts to go a bit nuts. Okay, and then finally, let's complete the circuit. And you know you've completed the circuit correctly because you can see, as long as you've got the show current on there, you'll see your little electron start moving around. And one of the things I really like about this simulation is it gives you a realistic idea of how fast the electrons actually move, i.e. not very. It's usually fractions of a millimeter every second. And I'm just going to tick these values on so you can actually see how I've got this set up. And we can see some current readings in our circuit. So that should be this circuit we've built here. And it wants us to record the current A1, A2, and A3. Well, you can see in here, it's 0.40 in all 3 of them. So the current, or the number of charges per second passing through a point, is exactly the same everywhere. Let's put all those in there. Okay, so now it wants us to repeat that process, but with 2 10 ohm resistors. So essentially we need to change this one to make it 10 ohms back where it was to start with. Ooh, a bit too far. Ah. Oh man. Is there a way of typing it? No, let's do. There we go. Okay, so we now got 2 10 ohms, and what you'll notice is these 3, they're still all the same, but now they're 0.3. 0.30, 0.30, and 0.30. So in terms of addressing the question, what do we notice about them? So you should notice that in a series circuit, which is what this is, so and they give the okay, so that's the key idea. So in a series circuit, your ammeters give the same current reading wherever you measure it. But when you increase the circuit resistance in the second experiment, what happened to the circuit current? Well, if we actually have a look at it, here it was 0.3, but before it was 0.4. So clearly, increasing the circuit resistance. And again, I'm going to be specific here because there are different rules with parallel circuits. So increasing the circuit resistance in a series circuit decreases, and it decreases the current everywhere in the circuit, as you can see. Okay, so that's our first one there. Now what we're going to do is start taking some other measurements. So it says it wants us to turn this one back to 5 ohms. So let's do that. Seems easier than trying to drag it. Okay, and then it wants us to measure some potential differences using a voltmeter. So that's this tool over here. So we can drag that. And it wants us to measure across the power source. So let's do that. That's V1. So that gives us a reading of 6 volts across the power source, which shouldn't be too surprising because that's what it says there. And then it wants us to measure across each of the components. So let's move that. There we go. Across that one. We can see we get 2 volts across here. And then let's go across there. And we get 4 volts. Okay, so V1 we got 6. V2 we got 2. And this one we got 4. And now we want to change this one back to 10 ohms. We're not going to have this again, are we? There we go. Okay, so first thing to notice is that this V3 value has already changed. It's now 3, whereas it was 4. And if we check these other ones, that one is now 3 as well. And if we go back to our first one, you can see that's still 6. We haven't changed the power source, so that one's not been able to change. So things to notice. So if you look at both of these setups here, you'll notice that V2 plus V3 are equal to V1. So we've got 2 plus 4 gives you 6, or 3 plus 3 is 6. And the other thing you might notice is that the smaller resistor gets a smaller potential difference, because remember, this one was the 5 ohm and this V3 was the 10. So you can see that the bigger the resistance, the bigger the share of the potential difference it seems to get. And we're comparing V2, so you can see that. So when we change V2 from a 5 ohm resistor to a 10 one, you can see it increase. So it's now 3 volts. So that's our actual data evidence there. And the V3, conversely, so if V2 plus V3 have to equal 6, if V2 goes up, V3 Okay, so that's what we've actually seen in our experiment there. Okay, so now we're changing to a parallel type circuit and looking at potential difference. So let's bin that circuit and start again. So let's change that back to 6 volts. Does it want us to record the current? No, it doesn't. So let's just stick some wires in. Now, you don't have to build it as neatly as mine. There are a lot of unnecessary wires in mine. I'm just trying to make it look like the diagrams that you have on the thing. So you can see, yeah, we got it working. We want that to be 6, and this one to be 10, and that one to be 10, which they are. And we want to measure the potential difference across them. So if we go across this first one, we can see it's 6. We know already that across here it's 6. And if we go across here, we measure a potential difference of 6. So here, so that one was 6, and that one was 6. Now we're going to change this one to a 5 ohm resistor. And you'll notice this one, unlike when we had a series circuit, this one stays exactly the same. It's still 6. And that one's also 6. So what do we notice about them? That's the first thing. So in parallel, the potential differences are same across both components. And in this case, the same as the power source. Now, this part in brackets isn't always true, because if I added another component in here, which I will just quickly do, so let's sever that connection there. So for example, if I stuck another resistor in here, now you'll notice the potential difference across this one is 1.5, across this one is also 1.5, so the potential difference across parallel resistors is always the same. But across here, you can see it's 6. So they don't have to always be the same as the power source. Reason being, we've actually got 4.5 across here. So there's 4.5 here, 1.5 there, and it still adds together to give 6. Okay, so does changing the resistor have any effect? The short answer is not in terms of potential difference. Okay, so it actually does have an effect on the current, which I will actually show you quickly now. It's not part of this, but it's interesting. So let's bin that one. let's get back to our simple circuit. We don't need that anymore. Okay, so let's put or get our gravity ammeter. So here we can see we've got a 5 ohm resistor here, so you can see the current in there is 1.2. This one is a 10 ohm resistor, so you can see the current is 0.6, so it's actually half. So changing these resistors does change the current going through them, but it doesn't change the potential difference across them. These two will be 6, regardless of what we do to the resistance. And what you'll spot here is that this is 1.8, so its current is 1.2, and 0.6 gives you 1.8. So actually in parallel, it's the currents that add together to give you the final result in there.